Welcome Class TV. I name myself Alibitosin. So this is elasticity part 5. Here we'll be taking calculations, and I want us to always take the calculation very serious. Why? Because most of the examination we're facing as far as physics is concerned are always calculations field, and you answering theories and not having the ability to attempt calculation questions in physics very well shows there is little or no knowledge you have in the topic. So that's why we always take my time to always treat calculations as far as it exists in any topic I'm taking. Now let's look at these calculations. Let's look at the calculation. I will call this calculation part 1. Yes, we still have more calculations after this. Now, a spring is stretched 40 millimeter. Is stretched 40 millimeter. That 40 millimeter refers to our extension E. We need to convert this extension E to meter. That will be divided by 40 divided by 1000 give us 0.04 meters. Now, by a force of 15 Newton, force is 15 Newton. Now we are told to find the work done. The formula for finding the work done in an elastic material, like I said in our previous class, is what? Now so we are given E and F, so we are going to use 1/2 Fe, and we are having 1/2 times our F is 15 multiplied by 0.04. This here 1, this here 2. So we have 15 times 0.02, and that gives us what? 15 times 0.02 give us 0.3 joules. That is unit for what? For finding our energy, elastic energy. So that is the first question. Now let's take the second question. For the second question, let's mark this as one we've answered. Now to take this one now, a spiral spring is compressed by 0.02 meters. Compressed, that's the extension, 0.02 meters. We don't need to convert this because it's already in meters. Calculate the energy stored in the spring if the force constant now, that is K. Force constant, that is K, is what? Is 400 Newton per meters. Now, we have to find the energy stored. The energy stored in a spiral spring is referred to as what? An elastic energy. So we say we have to find our elastic energy. Now, when we find our elastic energy now, we can say that what? Using work equals to half Fe. In this case now, we are not given F, so we rather use the second formula that says that what? Half Ke squared, because we are given K, which is what? Elastic constant. Now, note, we call it force constant here. It can be called force constant, it can be called elastic constant, and some question refers to it as what? Stiffness. So let's have that in mind. So this 1/2, our K here is what? 400 now, and our E is 0.02 square now. So this here will give us 200 now. Our 0.02 now, 0.02 square will be 4 times 10 raised to power minus 4, which can better be written as 0.0004 times 200 now, times 200 will give us 0.08 joules. That's the elastic energy, is 0.08 joules. Final answer for that question. Now let's take the third one. Now, the third question. A spiral spring extends by 5 centimeters. Our extension is 5 centimeters. And we said, okay, under a load of 60 Newton. Load is the same thing as force. Whenever you see any quantity given in Newton, you know it is a what? It's a force. Load, which is force as what? 60 Newton. When the load is replaced by a steel block, now when we replace the load of 60 Newton now by a what? A steel block, the new extension is 7 centimeter. Now we have to find the what? The new load that was replaced. Firstly, we need to know the elastic constant of the spiral spring. Determine the elastic constant of the spiral spring. 5 centimeter needs to be converted to what? To meter, so that it will be 5 divided by 100, 0. What? 0.5 meters. Okay, so now using F is equals to Ke, our F is 60 Newton, our K is unknown, and our extension is 0.05 meters. So we divide through by 0.05, divide through by 0.05. This cancels this now. So we say that our elastic constant now will be 60 divided by 0.05, and that gives us what? 1200 Newton per meter. That is the elastic constant. Now, what is now the force now when we have extension? That's the question. But what is the force when we have extension of what? We have extension of what? Of 7 centimeter. Okay, when you have extension of 7 centimeter, when E is 7 centimeter, it means we are saying we convert this 7 centimeter to meter now. We are going to 7 divided by 100, that's 0.07 meters. So what happens? What is the new weight now of the steel block when the extension is 0.07 centimeter? We've known our elastic constant, so we can easily say that what? The new weight, which is F, equals to the elastic constant. Elastic constant is 1200 now times what? Times 0.07 meters now. So that means our elastic constant now will be what? 1200 times 0.07 meters will give us 84. So which means that the new weight of the what? Of the steel block is what? Is 84 Newton. Now let me quickly add this. If you are given questions that if this kind of question appears in theory, we go this way. But if the kind of question appears in a case, probably you are writing an objective oriented examination, you could go this way. Alternatively, you can use the concept of proportionality. Yes, let me quickly chip that in. You can use the concept of proportionality for this. Why? If a force of 5 centimeter produces, if 5 centimeter extension is produced by 60 Newton of force. Now we are now asked that what will 7 centimeter extension, what kind of force will 7 centimeter extension produce? From proportionality now, we just cross multiply, so that it will be 5 times F, it will be F bracket 5 equals what? 7 times 60. 7 multiplied by what? 60. So divide by 5. Divide by what? 5. This cancels this. So we have 5 here 1, 5 here 12. So our F becomes what? 7 times 12, which is 84 Newton. So this is an alternative approach also for this question. So on that note, we come to an end of the first part of our calculation. The next video will still be taking more calculations to cement our knowledge on this topic. I name myself Alewi Tosin. Stay tuned.